Every time a large language model answers you, it is making a choice. Not because it knows the answer, but because it has learned what kind of answer gets rewarded. The learning process is called reinforcement learning, and today we are going to understand what tasks mean in reinforcement learning, what rewards are, what changing a reward slightly can change in LLM's behavior, and how different RL algorithms train modern language models. Imagine teaching a robot to pick up an apple. You don't tell it move the joint by 13 degrees. Instead, you say, task, pick up the apple, reward +1 if you succeed, and penalty is 0 or -1 if you fail. That's reinforcement learning. The robot explores, most of its attempts fail, some succeed. And over time, it learns which action lead to reward. Now replace the robot with a language model. Instead of moving arms, it chooses tokens, and instead of picking apples, it completes text. The model generates one token at a time, and at the end, someone or something judges the answer. The judgment becomes the reward. In LLM training, a task is simply what behavior do we want? Examples can be answer these questions helpfully, follow instructions, be harmless, show step-by-step reasoning, refuse unsafe requests. But here's the funny part. The same prompt can have different tasks depending on the training. Therefore, a reward is not a truth, it is a preference. For LLMs, reward often comes from human ratings, comparison between two answers, automated judges, and sometimes rule-based checks. The click becomes a signal. And that is not this is correct, but more of this is better than the other one. The earliest RL approach says if an action led to reward, do it more. If it didn't, do it less. In LLMs, the policy is the model, the action is choosing a token, and the reward is updating the probabilities. It works, but it's kind of unstable. PPO or proximal policy optimization adds a rule. Improve but don't change the model too fast. If the new model behaves too differently, the update is clipped. This made the RL practical for large models, but it still had problems. So RLHF was introduced, reinforcement learning from human feedback. And this adds a reward model which is trained on human comparisons. The reward model learns that the human prefers A over B. Then the LLM is trained to maximize that preference. This is how the models become polite, helpful, aligned, and sometimes sycophantic, but also overly safe, verbose, and sometimes evasive. Newer methods don't judge answers alone. They judge a group of answers. Instead of is this good, they ask which is better relative to the others. This is something that reduces noise, improves reasoning, and eventually stabilizes training. If you reward short answers, the model becomes terse. Step by step, models becomes out loud. If you reward safe answers, then the model refuses more. Same architecture, same data, different rewards, and thus different personality. So LLMs don't understand the world. They understand what gets rewarded, and thus reinforcement learning doesn't teach what is true or factual. It shapes the behavior of the model. And the smallest reward change can ripple into millions of decisions. So the next time an AI answers you, don't say it's not a smart model or it's a bad model. Ask what was it trained to reward. Alignment is not a switch, it's a reward function. If you want a follow-up video breaking down specific algorithms like PPO, DPO, GRPO, or how reward hacking happens, you know what to do.